Hey everybody, this is George Demers from Aerospike. I'm gonna wait just a minute or two just for any folks that are logging in, so stand by. But you're at the right place. This is 5 reasons to replace Redis with the venerable Ronan Botzer from Aerospike and myself from the product marketing team. And we're gonna start, as I say, in just a minute or so. In the meantime, I suggest maybe humming a little tune to yourself to provide music. And Ronan, how are you feeling today?
Dude, I feel venerated. It's pretty nice.
Good. That's only appropriate. All right. Bing, bing. Oh, by the way, there is a chat and a questions function in the tool. So if you have any questions or statements or comments, we're happy to hear from you. Despite the title, this is not trying to be a hit piece on Redis, but we find a lot of Redis installations when they get to a certain scale turn to Aerospike. We're going to talk about why that is and try to do it as dispassionate as we can. Uh, you know, no real big issues with Redis. It's a great platform. People love it, and it does extraordinary things. But as we've seen, at a certain scale, it starts throwing into some problems. And there's been recent excitement with Redis with their licensing announcement, but I'm not going to touch on that today. But for those of you who are in situations where you're using Redis and maybe you're starting to approach its limits, we hope you'll remember your friends at Aerospike and the amazing technology that our engineers have created. I'm 2.5 years into the company and still pretty amazed by our capabilities. So I'm happy to talk on the subject. And Ronan has long experience with Redis. In fact, if you want a good uh, dose of Ronan in his pure form, go and look up uh, that garbage benchmark video from an Ignite session he did. It is really something. So thank you for that, Ronan. Whenever I'm feeling down, I go and look at that video. All right. So 3 minutes past, we're going to start. 5 reasons to replace Redis. One is probably the most common, and that is for improved scalability. Aerospike lives in a rarefied air of the million, 10 million, 100 million transactions per second, while still offering very low TCO. Um, the design of Redis is very heavily dependent, obviously, on in-memory performance. So to serve large data sets, Redis clusters tend to sprawl. Um, they also, when you get to a certain scale, become a bit more predictable as far as performance, especially if the amount of data surpasses the amount of memory available to a Redis node. There is then the problem of the carbon footprint by running much larger clusters than you really need, and an associated cost efficiency reason. So we'll talk about each of these in turn. And first, we'll talk about improved scalability. This is probably the number one reason that people look to move on from Redis, especially for mission critical uh, workloads. Um, that is to say, I mean, Redis is running plenty of mission critical workloads, but up to a certain scale. So the question then is, Ronan, what is behind the scalability issues? First, it's the architecture itself. It was designed as an in-memory data store and cache. It's a single instance architecture, and they have in recent years added clustering and uh, replication and all that, but that's additional CPU overhead. Can you talk about that for a moment?
Yeah, of course. I mean, it was as opposed to Aerospike, Redis was never designed to be a distributed database. So a lot of the concepts, in order to make it work as a distributed database, you got to do several things. You either, use the old school approach where you shard it on the application side, and then, you manage that in your application, and adding nodes, dropping nodes, doing replicas becomes kind of a nightmare. Or you use a proxy, whether it's, the enterprise version of Redis, or, something that's been put out there by the community. Those proxies, which actually make it into a distributed database, because each Redis instance is completely unaware of any other instance around it. It's not aware that, how many cores are on the machine, or what the resources are, like actually anything really. That proxy requires CPU and memory of its own, right? So you run these things on the same host machine, and you must dedicate a certain amount of resources to the proxy layer. And that means less cores are available for Redis, because the instances are going to want to just go as hard as they can on the core that's given to them. So in the end, because it's not designed to be parallelized, and it's not designed to, share information across threads, or deal with like locking between threads or any of those things, um, you end up having these extra systems like proxying, like the persistence layer. If you're when you're dealing with any type of storage, you're putting in RocksDB, or whatever replacement for Rocks they're going for now. Those things by themselves are CPU heavy applications, and you start getting contention between them. The persistence layer also, is one of those dirty secrets about Redis when they publish benchmarks. They're always really happy to show you the numbers when there's nothing else turned on. Like, for example, not using persistence to an append only file, or RDB, or whatever the hell it was, persistence layer they're using. The second you turn those on, the fact that it's in memory doesn't matter anymore. The slowest component of the system is the one that's going to dictate the speed. The persistence layer typically creates back pressure, and that reduces the throughput, right? So there are issues to scalability, because in reality, you have to have a proxy layer. Every application in the world is actually a distributed application, and all databases need to be distributed data stores. And you must use persistence unless you're using it only in tiny caching kind of use cases.
Yeah. And we have a customer called AppsFlyer. They are a mobile attribution marketing analytics platform, and they migrated from Redis to Aerospike. Uh, and they deal with billions with a B of devices. So they went from dealing with 1.4 billion to 5 billion devices in the first year. So one of the kind of killer apps for an attribution company is reducing false positives, and that actually they were able to bring down to zero and enhance their accuracy. So definitely a mission critical for attribution and marketing analytics. So that is one proof point that Aerospike can scale. Actually, if you go to the Aerospike customer list, it is chock full of customers that are doing million transactions per second, 10 million, even I think the largest I've seen is 280 million transactions per second on an Aerospike cluster. Now, no one, very few companies need that type of throughput, that type of performance, but in terms of headroom, it's almost unlimited with Aerospike. So scalability, I think that's probably the least surprising for people that have tried to scale Redis. So that is number one. The second, the result of that scalability is that, as Ronan mentioned, uh, it really depends on having enough memory to house your data. So Redis really needs more memory than data. And then if you have really large data sets, you want to bring additional servers into play to provide a larger memory footprint. And so that means more servers. So only so much memory per node. and then the scale out because of a number of things that Ronan just mentioned. And then the result is more servers. That means more power, more HVAC, more data center real estate. It just uses a lot more resources. So we believe Aerospike is it's built into our design that we thrive on fewer higher density nodes. We don't actually rely as much on um, memory to get great performance. We have some really good high performance storage technologies built into Aerospike. So we think that smaller numbers of higher density nodes is the way to go. And one of our customers just they had an issue with the server usage and they wanted to improve their accuracy for their fraud prevention capabilities. They used Aerospike to reduce a 40 node Redis cluster to 6 node Aerospike cluster. So lower infrastructure costs and improved latency, better failover, better accuracy. So that that is a good example of how efficiency and these uh, smaller clusters with fatter nodes gives you a lot of benefits. Ronan, anything you'd like to add to that?
Yeah, I mean, there's a few things there. Number one, these higher sprawl clusters, again, related to density, you can only put so much memory on a machine. Redis also takes quite a bit of overhead, not something that they publish. If you go to Aerospike's capacity planning guide, there's very detailed explanations of like what are the overheads in terms of memory beyond the data you're actually trying to store. Redis tends to not tell you about that. So, uh, what they recommend is when you're running out of CPU or running out of memory, add more nodes. That's it. That comes down to capacity planning there. So as you keep adding more and more nodes, first thing, you may be in a situation where you're in the cloud and it's just harder to get the next node, right? Capacity, the cloud is not infinite. You go to an AZ, there's only so many machines that you have. If you need more machines and you need to scale it up, that becomes an issue, especially in busy periods like towards the end of the year. That's number one. Number two, higher mean time to failure. More machines just means more things are going down, more instability in your cluster. Um, and therefore also there's higher costs to manage it, right? Like when you have larger clusters, you need more systems, more people to manage and make sure that they're up and running. So the stability that comes with Aerospike, the reduction in the server cost, just the fact that it simply runs and works without needing to constantly manage it, all of those are advantages for that our customers have chosen to move to Aerospike from other systems, including Redis.
Yeah, and here's this is on our website. Just want to include it is uh, this is not just a Redis issue. It's hard, it's hard to scale distributed systems, and different platforms do better or worse at it. But one of the consistent reasons why people move to Aerospike is this efficiency, this uh, doing more with fewer nodes. So it's Redis, it's Cassandra, it's Couchbase up to a certain scale. These clusters, get very costly, and all those associated costs that Ronan just mentioned. So check us out. All right. Third challenge is predictability. And this is a lot to do with mixed workloads. Lots of databases do great with read-only workloads, but when you start getting mixes of reads and writes, and especially at a huge scale, lots of platforms have trouble with it, not just Redis. Um, but Redis does have an issue with this. The persistence layer causes, as Ronan mentioned, back pressure on the database, uh, and that balanced or write heavy workloads are especially susceptible to this, Ronan.
Yeah, because in the end, you need to actually log those to a persistence layer. Um, Whether you're using the old school append only file or some other thing, you are then going to be limited by the performance of the persistence. So the fact that it's in memory is all cool. If you're going to be a cache only, no problem. You don't need to have any of that. It could be volatile. You can go as hard as the system will allow you to go. But the second you actually want to use it as a database, that persistence layer is going to be the thing that causes a back pressure. Now, you can improve it by swapping all kinds of different persistence layer, but up to an extent, right? So these are things where the performance for any given read and write is not going to be consistent, right? It really depends of if you're writing to memory, if it's already in memory, or if it's on disk. If it needs to reach the disk, you're going to get, latency variations. When you're doing maintenance operations related to that persistence layer, something that is LSM tree-like that differs, doing like defragmentation and compaction, all of those will then kick in. You get these other behaviors that then constrain and give you, the throughput, and also give you less predictable latency that you'd want, right?
Yeah, and so Redis did a high-profile acquisition to attempt to solve some of these problems with the acquisition of SpeedDB, which is a fork of RocksDB. So that is, it does address a higher performance storage platform for Redis, and it's a little early to they have to go through the process of then integrating that with Redis and making it a seamless solution. But let's assume that that is on the way and people have tested it and it works. Uh, the the challenge with that is that those are two databases to solve one problem, and so they are going to compete for CPU and all the other threads that Ronan mentioned, the proxy and other processes that take up cores, take up CPU, and take up time. Uh, so uh, so SpeedDB is certainly an attempt to address that issue. Ronan, anything else we should know about that?
In general, anybody that's been an engineer is aware that handoff between threads is where you get contention, right? So the fact that you have completely different systems that are running on independent cores and threads means that you get contention on these handoffs, right? So first thing, it's they need to use different resources, and you cannot use all the cores on a host machine for Redis instances as one. But there's also just straight up contention in the passing over data that you need between one and the other. In Aerospike, we've really reduced those considerably, right? We have all these lockless data structure. We have the our threads that like literally do everything end to end, pick it up off the network, go and get information off of the storage device, do the work, put it back on the network card. There is no like thread handing off the thread, right? So we really work extremely hard to get the most out of parallelizing across all the cores and threads within a node. It's something that by design Redis cannot do as well. Okay, so that's one thing. The other thing is, I mean, SpeedyB, I'm sure, is great and better than RocksDB, but in the end, congratulations that, Redis now acknowledges that storage is an important thing. Uh, it's only starting about 14 years after Aerospike, where we've been putting a lot of work from the very beginning into very low level optimizations to get maximum performance out of the storage layer, basically using NVMe drives as the same way we use memory or anything else. It's all one unified um, sort of storage format across the different storage engines. And, you know, a bit late to the game. I mean, I'm sure SpeedDB is better than RocksDB, but for example, in our own benchmarking, Aerospike a long time ago was 4 times faster than RocksDB. If SpeedDB is twice as fast as RocksDB, it's still significantly slower than Aerospike, right? So um, I'm just, you know, great improvement for the Redis users, but it's going to take some more.
Right. So another part of that predictability is actually I'm going to spend very little time, and I don't want to let you loose on this one. But you had mentioned that Redis benchmarks are done without a persistence layer, which is great. You know, for in memory, you get speed, that's for sure. But the real test, especially for large workloads, is with a persistence layer, and we're eagerly awaiting to see what Redis will publish in that regard. But the other thing I'd like you to comment on, Ronan, is the nature of uh, how lookups are done, how key lookups are done with document data.
Sure. I mean, when you're doing a test in a key value system like Redis that has one data type for one key, if you're looking up one key, cool, it's very fast. But in reality, people tend to need to model with many data types, right? You have multiple strings, lists, integers, map data, etc., that you need to represent an object with. In Aerospike, all of those are in one record, right? Single key. You can have all the data types side by side, similar to an RDBMS table, but you don't have a schema, so you can add and drop them at will. They can be there or not be there, and the application continues to work. So if somebody needs to update multiple fields or read multiple fields that are associated logically with one object, in Redis that requires lots of key lookups, right? You were going to need to do multiple keys to get basically assemble one document together. Whereas in Aerospike, that is a single key lookup. And that's where we see actually in our own customers significant improvements in latency. Even though Redis is allegedly the fastest database in the world, the fact that once you're modeling an object as a set of keys, you're going to need to update multiple keys or read multiple keys or do a combination of those. And in Aerospike, you can do these multiple operations, single record transactions that have multiple operations all under one key access, one lock. And that in itself gives much better performance, even when you're serving data out of SSD.
Great. And one good example, by the way, I should mention that this webinar really is based upon a blog that I created, which really just talked about these customers who have migrated from Redis to Aerospike. So another example, and germane to predictable performance, is Iron Source. They're an ad tech firm. We have a lot of those as customers because they have very tough database requirements. They wanted a more dependable solution, um, and to be more efficient, um, and they were able to enhance their performance with 130K reads per second and 75K writes per second, with nearly 100% uptime with sub-millisecond latency. So this is another kind of common theme with Aerospike customers. I've heard dozens of times the customers saying it just works, and that means uptime. A lot of customers really are approaching 100% uptime for years on end. So something we're really quite proud of. So they got more efficient with their ad serving, and that efficiency enables new use cases, new business capabilities and functions. And what really does that, Ronan, is our hybrid memory architecture. So let's take a moment to describe what that is.
Sure, at large, before we even get to the storage layer, it, the Aerospike client is fully aware of the partition map, so it can get to the correct node in one hop. It doesn't need to communicate to anything else. It doesn't need to have a proxy. It doesn't need to go through some name node. It knows always, and it keeps track of the cluster changes. So it knows how to get to the correct node with a single hop. Um, on that machine, the data is looked up, the metadata about that record is looked up in the primary index, and that is, a hash table in front of a collection of RB trees. So it's very consistent to find the metadata no matter how many pieces of data there are. Whether you have 10 million or 100 billion objects in your cluster, the kind of amount of time it takes to find the metadata is the same. So once we find the metadata about the record, these 64 bytes, which by the way are cache line optimized, so that's exactly what the CPU expects ideally. Those 64 bytes tells us exactly which device the data is on. If you're storing it on SSD, you could also do it in memory or on PMM, but it's exactly what device it's on, what the byte offset is to the beginning of the record, and then basically how far ahead we need to read, right? So one IO gets you your entire record because it's stored contiguously. Now, this plays to the strength of SSDs, which allow you to do a very large number of concurrent read and write operations all at once, right? So Aerospike is highly parallelized in order to take advantage of the highly parallelized nature of SSDs. So we get extremely high throughput by using these optimizations. We bypass the operating system. We don't use like a page cache. It's direct raw device access, where Aerospike is managing information about the blocks that it writes. It writes in consistent block sizes, which really maximizes write throughput. And the other thing is that we do defragmentation operations continuously in the background. We don't treat things like an LSM tree, Cassandra, RocksDB, whatever it is, where we just keep taking writes, and we just defer the compaction that needs to eventually happen to later. And once that happens, you get spikes in latency because of all the disk I/O. So defragmentation is this constant background amount of disk I/O that's being kind of attacks on the system, but it also creates a situation where you don't get big latency fluctuations. So really, Aerospike from the ground up was designed to be a distributed database, and from the ground up designed to use NVMEs as primary storage. Now again, Aerospike allows you to use persistent memory or shared memory, meaning actual RAM, as the storage engine. But in the majority of configurations, the use of SSDs is at the most optimal possible way. And that is what gives us latency and throughputs that are competitive with a purely in-memory system like Redis.
And we do it actually at different price points and for different use cases for different reasons. So in memory, of course, is the fastest, and it's great when you can afford that, and you get the lowest latencies, and we have customers that are using up to terabytes of data in these configurations. Then you have the hybrid memory, the use of memory and flash technology that Ronan just described. You can run Aerospike in an all-flash configuration, and then we have just introduced in Aerospike 7 the support for networked NVMe compatible storage, like network attached storage from someone like Dell or what have you, as well as NVMe compatible block storage in the cloud with Amazon's EBS, and Google and Azure both have block devices you can take advantage of. So you can obviously deal with tons and tons more data, and you'll have some higher latencies. I mean, still less than 10 millisecond latencies with these networked block devices. So basically, you get to kind of choose your price point, choose the best option for your needs, and that is something that Aerospike has kind of fanatically gone after. Ronan, anything else you'd like to add with that?
Yeah, look, in something like EBS, there are different variants, right? So something like an IO2 version of EBS gives you sub-millisecond latencies, and you just pay for what you use, right? So we've benchmarked it, and definitely for slightly lower throughput use cases, what's nice about it is you get much better economics. You get the ability in something like AWS EC2 to be able to just provision compute nodes that don't have locally attached SSDs, and then get as much EBS as you want with it, right? So first thing, you control the ratios, as opposed to the storage optimized instances that have a constant ratio between RAM and disk, which typically works for Aerospike users. If you have your 64 bytes of metadata in memory, if you're using the primary index in memory, and then you have, let's say, a K on disk. That works really well with instances like I4I, right? But you may want to have a different ratio. You may also have slightly lower throughput. So there is like an inflection point, and that's something that we can work with customers if they're interested, where it's cheaper if you have higher throughput to actually get these storage optimized instances, but beneath it, it's cheaper to get, some instance that has CPU and memory, and attach as much EBS as you want to it, right? So the point is flexibility, right? There could be reasons that somebody wants to use an in-memory database. It may be because they just create software that needs to be deployed on all kinds of hardware and they can't ensure consistent, good NVMEs. But it also could be because they want to get things in the low, hundreds of microseconds rather than sub-millisecond, right? It could be all kinds of things. The point is we want to allow customers to have the flexibility to decide what is the hardware that fits their use case best and the cost performance associated with it, right? Aerospike is agnostic of these storage layers. Doesn't need to be in memory, doesn't need to have any kind of demands, high memory demands, right? Which is why you can get a much smaller node count with Aerospike, right? So these are things where we've worked really hard to do support for all these different storage engines. The other thing to point out is that Aerospike cluster can have, up to 32 namespaces. Those namespaces can each have different configurations for storage. You can have an in-memory cache that basically has no persistence at all. You can have an in-memory database next to it that has data stored in memory but persisted to EBS. You can have, also have ones that store just the primary index in memory, 64 bytes per object, and then data on SSD. And you can do it all in once in a single cluster in order to basically use less hardware to do more stuff, right? Support different applications with different characteristics. So that's a nice thing about Aerospike.
And once again, returning to scale, we have numerous customers that are dealing with petabytes in a cluster. But as everyone knows, everyone is seeing more data that looks good and wants to be thrown into the equation. So the ability to handle petabytes or even tens of petabytes requires some serious thinking on the finances. So you want these kind of low cost options. Actually, Ronan, this feature, the support for EBS in particular, was actually, I believe, a customer request that didn't need, sub-millisecond, but they needed petabytes.
Well, they did want to get as lowest latency as possible. Um, the point was just not necessarily the throughput, per device, operations per second per device was not necessarily one that required them to use, local SSDs that are like nice NVMEs. So we just want to basically allow people to create applications on one platform. A developer can use a single container instance on their laptop, a million objects, 10 gigs, whatever, for test data, hand it over to an SRE team that is actually running a 60 node cluster with 200 terabytes on it, right? The point is that you should be able to decouple development from the concerns of the SRE side of the world. It is kind of bad design to require you to have in your own code access to caching layers and disk-based caching and then like the actual database and do workarounds for the operations system in the code itself, right? Like where to find the data, because you want to make sure that the production system doesn't fall on its face and catch fire, right? So the fact that Aerospike is a distributed database that performs as fast as any in-memory cache, that can scale to petabytes. You can test on 10 million objects, but you can actually run the system with 100 billion objects and have petabyte scale, and that is used by our customers for many, many, many years. Some of them 10 plus years in production. There is a proof point that you don't have to worry about your own growth, right? So these options are really given to the SRE side of the world. A developer doesn't need to care about any of these things, right? Whatever they do on their laptop should then ideally work without any workarounds, spaghetti code to address a big complex tech stack that's only purpose is to make sure that things roughly perform okay in production. We know that Aerospike in production gives that performance regardless of where you store the data, right? The SRE team may need to have different considerations on like what is the ideal, kind of cost performance, right? Like you may not want to put data in memory because you have a petabyte and you don't want to have like 1,000 nodes to do it. Or you may say like, I don't want to use an NVMe device because it's mostly sitting idle. I just want to use EBS where I know I can pay for a certain consistent performance, get low latency, pay for the operations, but really get guarantees from the vendor itself, and then not need to have a really, sort of monster NVMe that's mainly sitting idle. So the developer can develop their applications. The SRE team can choose where they deploy things in a way that makes the best stability and the most kind of cost efficient decision, right? So that's what's nice about this.
Yeah, and that actually segues nicely into the fourth reason, and that is sustainability and carbon footprint. With all that is going on with AI and LLMs, and as as well as blockchain and other things that are you know using incredible amounts of compute and electricity resources and so forth, that uh, IT organizations are starting to look at this. It is also a cost center, energy and HVAC, et cetera. So having large sprawling clusters don't really help you meet efficiency and sustainability goals. And that's, the bad math is that CPU and memory heavy operations consume energy and generate heat. It's just the laws of physics we've been dealing with, but it's getting more and more crucial that companies uh, start to address this. The number of servers, uh, the data size is divided by the available RAM per server in these in-memory systems. So once again, the scalability, the server sprawl we've talked about, all affect the amount of heat and generated and amount of electricity used, and also uh, technologies that underutilize CPU, that can't really efficiently take advantage of multi-core processors. Um, they actually have an impact on carbon footprint and save the planet, man. So that was an issue at TomTom. They're a navigation and mapping solution provider, and wanted to slash their operational expenses and shrink their environmental impact. So they were able to reduce their carbon footprint by 86%. They lower their operational costs. They are definitely related. And in the meantime, with Aerospike, they were able to improve their reliability and uptime. And uh, I'm not going to go through the video here, but um, efficiency, before sustainability was cool, Aerospike was fanatical about efficiency, about the use of memory, about how writes operate, how memory is used. So server reduction is a big part of the reason why customers choose Aerospike. But the knock-on effects of way less carbon footprint and add to that improved TCO, and it is something that is a perfect fit for an Aerospike cluster. Oops. Oh. All right, let's skip the video. All right, and then the final reason is cost efficiency. That scale out inefficiency really translates directly to cost efficiency. It requires much more memory, more nodes, higher, that equals higher costs. Uh, Then the inability to use denser storage requires more machines. Uh, server sprawl becomes a budget sinkhole. Large clusters also require just more human resources. So the SRE teams have to do more with larger clusters. It's just the way it works. So this is very related to the other reasons, but once again, a big reason why Ronan, why people turn to Aerospike is we strive for the most efficient and the highest uh, efficiency and the lowest TCO possible.
For sure. Look, it's all about in any organization, it's about efficiently allocating resources, right? When you have less people that need to deal with keeping your infrastructure, and a database cluster is the infrastructure of any modern application, less people doing that can just be doing other things, right? Other automation, other development. Um, you know, instead of developing your own database, switching to something that's already out there that has, over a decade of very heavy production use case in all kinds of different configurations. Like we said, different storage engine for the data storage, different scales, different number of objects. I mean, trillion object databases, multi-petabyte databases. Aerospike is used for all of those things, right? Incredibly high uptime, very little resources relative to any other competitor to run these extremely large clusters. That just means you can use your resources elsewhere. People that have been developing the in-house database, or the how do we rubber band a solution around Redis and other layers in order to make it into a distributed database, or just simply to run what is out there. Um, you could do other things with those people, right? So that's the whole idea of what we're proposing on the human side of things.
Yeah. And one company that took this to heart is Wix. Many of you know them, the web development platform. They have, a lot of personalization features. They wanted to enhance them, do more while cutting costs and reducing latency. So they were able to migrate from Redis to Aerospike, reduce their costs by almost half, and lowered their latency from 18 milliseconds to just 2 or 3 milliseconds. And as Ronan kind of hinted before, you know, database operations are often they're often multiple operations to accomplish one task, and so 18 milliseconds to 2 to 3 doesn't seem like much, but if that is you know 20 puts or 20 gets or whatever, that starts to add up. So they were able to improve their personalization and their user experience and reduce their costs, and good on them. So we're getting near the end. The last thing that was our 5 reasons. The last thing I wanted just to mention on top of the efficiency we talked about, um, we we are a multi-model database. So we support. We are a NoSQL key value database, but but data has become more and more expressive, and documents were a good way to express more complex data. But nowadays, graph data and vector data are becoming really more important. They're much more expressive, and they can attack much more complicated and sophisticated problems of identity, of fraud, of creating knowledge bases, and then of course the whole AI/ML revolution, image recognition, LLMs, similarity searches, all getting much more sophisticated, much more interesting. And Aerospike has support for all these different data models. So that kind of brings us to the end. I want to just point to some resources on this topic. The blog I mentioned first is really the genesis of this webinar. Redis replaced 6 case studies in superior performance by yours truly, and a team of folks with Ronan's gentle guidance. Same thing on the website itself. There is a comparison of Aerospike and Redis. It goes into some good detail. Ronan has reviewed and blessed it. So it's not just a marketing fluff piece, I hasten to add. And then finally, you know, I mentioned at the top of the hour that the change in licensing has kind of stirred up a hornet's nest for Redis. I did create a blog that talks a bit about what it means. So take a look at that. And Redis, Ronan, do you have any final thoughts for people that are thinking about Redis and Aerospike?
Yeah, I wanted to point something out. Whereas Redis, community, what is out there for people to use, um, is one thing, right? But in order to get into production, like I said, you have to figure out persistence layer and proxying, and those are not things that are available to the public, right? You need to actually pay for a solution out there or cobble something together. Aerospike Community Edition is the exact same database as Aerospike Enterprise Edition underneath it. The difference between them is a bunch of modules that are put on top of it, right? Security and, encryption at rest and compression. These are all things that are added on top. The actual database is literally built around the core. So Enterprise Edition is built around the core that is the Community Edition. They have the exact same performance. They come with a whole distributed database thing out of the box. There's no like attach a proxy to this single, threaded thing that is Redis, right? All of these things, the same exact API, the same performance. We don't, hobble. We're not like Cassandra versus DataStax that is a complete reimplementation. One of them is like the database is completely different. This is exactly the same database, right? So this is what we have out there. People can start with Community Edition and have like adjust that you mentioned and move to Aerospike. The performance didn't change in any way. Operationally, it became easier to run, right? Or you had more features on the operation side. But like, we don't play games with people. We're giving them the same exact database. We test the same exact database. The performance, all of these characteristics are exactly the same thing. So I just suggest, I was a Redis user in the past and I really love it, and it still is fantastic, and I get why developers use it. Um, I think Aerospike is a fantastic database. It used to be exactly only in the ad tech niche, and if you weren't in that industry, you didn't hear about Aerospike. But like the second I heard about it, I understood immediately that I could have used it in many projects in my former lives, right? Its performance, its simplicity, the fact that I don't need to write spaghetti code for sharding and caching or any of these things, all of it makes for a much simpler application. Um, I was very excited, and that's the reason I joined Aerospike at the time. So I really suggest for people to just try it. You can get a Enterprise Edition downloaded. It's a single node instance, which is all you need as a developer. That's its only limitation. The entire feature set of Enterprise Edition is out there for you. Community Edition is there for you to use in production. You can use a 60-day trial of Enterprise Edition. Give it a try, right? The point is you can develop an application and not worry about your growth crushing you in the future. So I would suggest taking a look at it.
Wonderful. So that brings us to the end. The 5 reasons to replace Redis: improve scalability, reduce server sprawl, have more predictability within your performance parameters, reduce your carbon footprint. Save the planet, man. And finally, cost efficiency. Everyone wants to save a buck. So that is our presentation today. I want to thank Ronan Botzer, venerable product manager from Aerospike. And with that, I'm going to say thank you to you all. You can get in touch with us, and as Ronan suggests, try the product. You can, do Jupyter Notebooks, and there's a great developer a hub on aerospike.com, and or that 60-day free trial that he mentioned, or the community edition. So lots of ways to play around with Aerospike. We've just, you might have read, raised $109 109 or 115 million, I forget the exact number, of new funding. So we're going to work on making it even more fun for developers, add new capabilities, and we're off to the races. So once again, thank you very much, and I hope you have a great day. And that ends our presentation for today. Thanks very much.